Okay, this lesson is on quadratic functions, and the first thing we're going to talk about is when a quadratic is in vertex form, and it looks something like this. In vertex form, you can tell which way the graph has been shifted. A minus is going to shift it right, a plus is going to shift it left when it's inside the parentheses, and then on the outside a plus is going to move it up and a minus is going to move it down. And so you can easily locate the vertex. In this case we went right B and up C, so our vertex would be at BC, but you guys know your shifts, so if you just think about that, you should be able to come up with whatever vertex is needed from this form. So our first example, we're just going to sketch and find the vertex for y equals x minus 3 squared, and you might want to note that this has been moved right 3, and so it's facing up because you don't have a negative out front. So if I just draw a parabola that's moved right 3, I can tell that the vertex would be at 3, 0, but I could also look over here at the formula and realize that you've been moved right 3, so it would be a positive 3 for the x value, and then there was no plus or minus outside, so that would be 0. I can look at the equation or the graph and tell that vertex. Example 2 is also in vertex form. Even though it doesn't have the parentheses, that just means that it's like plus or minus 0 inside. But you can tell what this graph is like from the shifts. So this has been shifted up 4, and even though they're not asking that, it's kind of helpful when you're trying to draw it. So 1, 2, 3, 4, it's face up because there's not a negative out front. So there's our graph, and you can tell that the vertex would be at 0, 4. So those are probably two of the most simple examples that we could do. Okay, example 3 has a little bit of change for both. We have a move left 1 and down 5. And so if I sketch that one, left 1, down 5, again, this one is still face up because I don't have a negative up front. But regardless of whether it was face up or face down, the vertex would still be at -1, -5. It's just if it had a negative out front, the graph would look like it was flipped vertically. And so that is our combination of changes in our vertex form. Okay, so the second thing with our quadratic functions that we're going to learn is about standard form. And standard form is good for other reasons than graphing. It's good for finding zeros and things like that using quadratic formula. But if we want to graph it, we really need it to be in vertex form. So the first thing that we're going to learn how to do is to convert from standard to vertex. What we're going to have to do is a process called completing the square. You see that name in our step 3. We're going to get the stuff with x's on one side and the plain number on the other. That would be the c. We're going to move it to the other side. If there's a number in front of the x squared, it becomes a little bit harder of a problem. We're going to factor it out. Completing the square, these two steps right here, and then this third step, I guess, adds in a little bit, is the big thing. If somebody asks you to complete the square, you're going to take half of the number in front of x and square it. And then usually you're going to add it to some places. The way I set my problem up, we're going to be adding it to both sides. If we had factored that number out, if there was an a that was something other than 1, we would be multiplying before we add to the other side. And you'll see what I'm talking about when we get into a problem. I just wanted to have all of these steps written down so that you can remember and refer back to it when you're working your homework problems out. Your next step is factor, and it's always going to factor really easily, and I'll show you that. And then we'll move that plain number back over by adding or subtracting, and it should be in vertex form at that point. So again, those steps are really for you to look back and refer to later. So once we get into these examples, you'll understand what we're saying. Alright, example 4. We're going to start off with some fairly simple ones that don't have numbers in front. This is going to look really weird, and this is kind of my method. It's not really something that it's in your textbook, but it works for me. We're going to subtract that 15 to the other side. And again, it's going to look really weird when you say f of x minus 15, but don't worry about that because it's not going to end looking like that. And you're going to leave the stuff with x's on the side together. So we just move the plane number, that's our step 1. Step 2 is to complete the square. And we didn't have that number in front, so right now we're just doing the basic idea. You take half of the number in front of x, which is 8, and you can think of it as negative 8, that's fine, but you take half of it, which is 4, or negative 4, and you square it, that makes it positive. That's why it doesn't matter whether it needs to be negative or positive. So I just think of half of 8 as 4. 4 squared is 16. You add that to both sides. When you're looking back at your notes, you're going to be like, where did this 16 come from? It's like it's pulled out of thin air, and it almost is. You're getting it by a method. Again, half of 8 is 4. 4 squared is 16. Now, the fact that you add it to both sides is where learning to do equations comes in. An equation is kind of like a set of scales where you're weighing things and measuring things and you want them to balance. If you add 16 to one side, you add 16 to the other so that they're still balanced. So that's the main idea there. On this side over here where you have the f of x, you can combine those numbers. So I have 16 minus 15 is just 1, so I put plus 1 now. This side over here on the right is always going to factor into 2 parentheses. Both of them are going to have the sign that is between the x squared and the x, so in this case that's a minus. They'll both be minus. And then you get this number here from looking at either half of 8 or the square root of 16. So half of 8 is 4. These two will always match. Okay, so this is a lot easier to factor than thinking about the x factor stuff. These will always match. That's completing the square made that happen. And then I want to, before I move this 1, I want to write this as x minus 4 squared. And if you get good at this, you can just skip from this step right here to this step right here. You don't have to write it twice and then combine it as squared if you see where it's going. And then our last step is to subtract that 1 back over. So f of x is x minus 4 squared minus 1. And you'll notice that is now vertex form. My vertex for this is at 4, negative 1. And I could sketch the graph if I wanted to, because this is now in the form of those easy examples that we did at the beginning. Okay, example 5 is another example where you don't have a number in front. This might be a good one for you to try if you want to pause and try it. Okay, so hopefully that you started this off by subtracting the 25, so you would have f of x minus 25 equals x squared minus 10x. Then you're ready to complete the square. So half of 10 is 5, and 5 squared is 25. So you're going to add 25 to both sides. Now what's nice is over here on the left you have 25 and negative 25, or 25 minus 25, which goes to 0. So you actually just have f of x there. This right side is going to factor. The sign is going to be minus because that's the first one here. And then half of 10 is 5. So you get x minus 5 twice. And again, you could skip this and just jump to x minus 5 squared if you want to. And because I didn't have a number left over here to move back, this is considered vertex form. It's just a parabola that has been moved right 5, so our vertex would be at 5, 0. That was a fairly easy one. Okay, example 6 starts where we have something in front of the x squared, and so that adds one more layer into the problem. I'm still going to start by moving that plain number to the other side, so I'm going to subtract 21. And that leaves me with negative x squared minus 4x. Whatever that number is in front of x squared, you want to factor out like it's a GCF. So I'm taking out a negative 1. That will leave me with x squared plus 4x. And then I want to leave some space before I close that parenthesis out. I haven't messed with the left side yet. Now, if you remember, when I talked about completing the square, we're going to get a number right here to add. And the sides have to have the same amount added to them. And that means that this number is actually multiplied by -1. So when I go to the other side to figure out what to add, I need to multiply by that number in front. So let's find that number. Half of 4 is 2. 2 squared is 4. So I'm adding 4 in this parentheses, but I'm really adding a -4 to this entire side, because if I distributed the -1 back in, I would get a -4. So I'm really adding -4 on this side. I need to add -4 on the other side. Basically, you can take that number that you found, multiply it by the number in front of the parentheses, and put that on the other side. Okay, on that side I have -4 and -21, which will be -25. On this other side, I'm going to have my -1. I'm going to go ahead and factor that. I'm going to do that skipping down to x. The first sign is a plus, and then half of 4 is 2 squared. So instead of writing it twice, I'm going to write it squared. And then I have to add the 25 back over. So I have negative, I'm just going to write the negative this time, x plus 2 squared plus 25. And from that, I can tell that my vertex would be at -2, +25. If I were graphing it, it would be flipped because of the negative. Okay, example 7 is similar to example 6 because we have this 2 in front of the x squared. Before I start, I want to move that 7 by subtracting it to the other side. So f of x subtract 7 equals 2x squared plus 8x. Now, because I have the 2 in front of the x squared, I want to factor it out like it's a GCF. So take out the 2, have x squared plus 4x, and then leave some space. Then I'm going to complete the square. Half of 4 is 2, 2 squared is 4, so I'm adding 4 inside. But really to this entire side, how much am I adding? 8. Because that 2 would be multiplied by that 4. So I need to add 8 on the other side. So over here I have f of x plus 1 because 8 minus 7 is 1. I'm going to bring down the 2. I'm going to factor to x plus 2 because you bring down this sign and half of 4 is 2 squared, and then I'm going to subtract my 1. So I'm going to have 2x plus 2 squared subtract 1, and I can tell we've been moved left 2 down 1, and we have a vertical stretch by multiplying our y's by 2. But I'm just going to tell what the vertex would be in this case, which would be a -2, a -1. Okay, the next thing that you need to be able to do with quadratics is to find the zeros or x-intercepts or roots or solutions. All of those words mean the same thing. So if it says find the zeros or find the roots or find the solutions, they're all asking you to do the same thing. In every case, get everything equal to 0. In other words, put it in standard form so that it equals 0. Because whatever you choose to do to solve after that, it needed to be in standard form to begin with. There are 3 options to solve. One, you can factor and set those pieces equal to 0, which is, if it factors, usually the easiest route to take. If that doesn't work, the quadratic formula always works. You may get i's, you may get things with square roots in them. And then if you have a calculator and you want to graph it and calculate the zeros, you will have to use that second calculate button, but it will give you the same answers that you would get from the quadratic formula. It would just be in decimal form if they're real numbers. However, if the parabola does not cross the x-axis, you would have to use the quadratic formula because that would mean the answers would have i's in them. So let's go down to number 8. We're going to find the zeros or solutions for it. And we already have everything on this side, so I'm going to set it equal to 0. And this looks like something that might factor. I'm going to take out a -1 just because I don't want that negative in front of the x squared. I don't want to have to think that hard. So I'm going to have x squared minus 6x plus 8. And this will factor. If you think your x factor, you have 1 times 8 is 8, and then you want -6. So that would be a -4 times a -2 to make a positive 8, and then they add to get a -6. So you have x minus 4, x minus 2. So this negative out front is like having a -1. And you can say 0 equal to -1, but that doesn't make sense. So you really throw that away unless it has an x with it. Then I have x minus 4 equals 0. So if you solve that, you get x equals 4. That's one answer. And I have x minus 2 equals 0. If I add 2, I get x equals 2. So that's a second answer. And I'm supposed to have 2 answers because it is a quadratic. Okay, 9 again is something that's going to factor really easily. Don't forget your perfect squares. Now this is not x squared minus 36. This is 36 minus x squared. So when you factor it into perfect squares, you're going to have 6 minus x and 6 plus x. And then those you just set equal to 0. So 6 minus x equals 0. If you add the x, 6 equals x, or x equals 6. And then 6 plus x equals 0. If I subtract the 6, x equals -6. So positive 6 and -6 are answers there. That's another example of factoring. Now occasionally you'll get one like 10. This one is in vertex form, so picking out the vertex is easy, but the zeros are not as easy. To get the zeros you need to be in standard form. So I'm going to have to set it equal to 0, but I'm also going to have to multiply it out and put it in standard form first. So I'm going to write this twice and use FOIL. So x squared plus 2x plus 2x plus 4 minus 5 gives me x squared plus 4x minus 1. And then I look at that and I'm thinking, okay, I don't think that factors, because if I do my x factor, 1 times -1 is -1, and I'm trying to get 4. There's nothing I can multiply to get a -1 that's going to add to get a 4. So that leaves me with either quadratic formula or graphing. And just for the practice, we're going to do quadratic formula. So our a would be a 1 because that's what's understood in front of the x squared. Our b would be 4 because that's in front of x. And then our c would be -1. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a, just in case you've forgotten it. And so I'm going to plug in what I have. I have -4 plus or minus the square root of 4 squared minus 4 times 1 times -1 all over 2 times 1. So that's going to give me a -4 plus or minus the square root of 16 plus 4, so 20, over 2. And then the square root of 20 is going to break down. It's the square root of 4 times the square root of 5. So that's going to be 2 square roots of 5. And then I want you to notice here I have 4, 2, and 2. Those things, when they all have something in common, can reduce. So this is actually -2 plus or minus the square root of 5 over 1, which we normally don't write. So this would be the two answers you would get from the quadratic formula. One is -2 plus the square root of 5, and one is -2 minus the square root of 5. You could also graph this and find the zeros. So a perfectly acceptable answer would be getting the graph zeros of 0.236 or 4.236. Okay, that's the same thing as this square root. It's just in a decimal form, and that's what you would get on the calculator if you graphed. Okay, so for number 11, when I look at this one, because that 1/3 is there, that's going to make factoring hard to think about, quadratic formula hard to think about. So I'm going to graph this one in my calculator. So let's take a minute and type it in. And if you're using our school calculators, you don't have a fraction button. You just have to type in 1 divided by 3. But if you graph this in a standard 10 by 10 window, you can actually see what you need to see. It does dip down below the x-axis and come back up. I'm not sure if that's at 0 or not. I'm just kind of giving you a sketch of what I see on my calculator so that you have an idea of what you should be seeing on your screen. When you have that graph up, you want to hit second trace, which takes you to the calculate menu, and you want to hit number 2, which is 0. It will then ask you questions left bound, and you want to get on the left side of one of your zeros. And I'm going to choose this one first. And so I want to come to the left side, which will be above this axis, and get about right here and hit enter. And then it will pop up with right bound. You don't want to go all the way over because it can't do 2 at once. It can only do 1 0 at one time. So go to the right side of this 0, which happens to be below. So somewhere down here, and hit enter. When it says guess, you can try to get on top of the 0 you want, or you can just hit enter. It'll find it. And it's giving me that this point right here is at negative 1.816, so 1 negative 1.8 would be fine. You have to repeat that process to get the other one, so you have to hit second, calculate again, and then choose number 2, the 0. And now you have to arrow over when it says the left bound to the left side of the other one. Well, the left side of this 0 is below, so I'm going to hit enter about right here. And then the right bound's going to come up, so I got to go to the right side of that point, which happens to be above. And then on guess, I can try to get on that 0, or I can just hit enter. And so that's not crossing at 0. It's actually crossing at negative 0.18. So here are two answers. Negative 1.8 and negative 0.18 are the answers for number 11. Okay, 12 and 13 are good ones for you to try on your own. So if you want to pause, you can, and try those on your own. Okay, I did number 12 by factoring. You could have graphed it, you could have used quadratic formula, but like I said, I tend to use factoring whenever possible. In this case, everything was divisible by 2, so if I took a 2 out, that gave me some easier numbers to work with, and it easily factored into x minus 3 and x minus 5. Again, when you have a number out front, if you set it equal to 0, it doesn't make sense, so you toss that. If there's an x with it, you would end up having an equation to solve. But there's not in this case. And so then I just had the x minus 3 equal to 0 and the x minus 5 equal to 0 to solve, and I got 3 and 5 as my answers. But you would have gotten those on the graph, or you would have gotten those using quadratic formula, whichever way you chose. Okay, 13 is another one for you to try on your own, so hit pause and try it on your own. Okay, so I also chose factoring for 13, but again, you could have chosen quadratic formula or graphing. When you factor this, you have to remember that you have that 2 in front, so after you come up with a negative 5 and positive 2, you have to divide those by 2 and end up swinging this 2 to the front on this one and reducing to 1 on this one. That makes, again, two simple equations for you to solve, but again, you would have gotten these same answers in the other two ways if you had chosen to do so. Okay, the last part of our stuff for quadratics is being able to write the equation from the points, and when we have the zeros, you can just work backwards. If you think about how you get an answer of x equals negative 2, that came from a factor of x plus 2, like we just solved in our last few problems. And an x equals 5 came from x minus 5. So if you think about where they come from and are able to back it up, you can just write your equation from those two factors, x plus 2 times x minus 5, and you just have to multiply it out. So we get x squared plus 2x minus 5x minus 10. And then in standard form, we would have x squared minus 3x minus 10. Just as a side note, you could also have those same zeros if you had a quadratic that was facing down. This one happens to be facing up, by having a negative out front of that. So I'm going to put or. You could have one that was negative x squared minus 3x minus 10, which if you distributed, you would get negative x squared plus 3x plus 10. Because they didn't tell you whether the thing was face up or face down. You actually have two options. One is it crosses the x-axis at those two places and is face up. The other is it crosses at those two places and is face down. So you actually have two possibilities here. You just need to find one, but you need to understand that you have more than one. And actually, there's more than that because I could have vertical stretches. We're just not factoring that in at the moment. Okay, for 15, the 4 is easy. That came from getting x minus 4. If we solved that, we got a positive 4 out of it. Getting the negative 1/2 came from one of those, like when we x factor, we had that number we were dividing by. So if you think about from an x factor point of view, it would have been something like this, but we would swing that 2 to the front. So it's really x minus 4 times 2x plus 1, because if I solved 2x plus 1, I would get the answer of negative 1/2. But it's the same thought process again as factoring and having that number you divided by. So if I multiply those out, I'm going to get 2x squared plus x minus 8x minus 4, which would simplify to 2x squared minus 7x minus 4. And this is the face up case because it is a positive 2. Again, I could do a negative 2, which would change all of my signs. And so either one of these is your option. They're just passing through these 2 points on the x-axis. Okay, 16 and 17, we're giving you a different set of information. Instead of zeros, I'm giving you the vertex and a point on the graph. Well, if you know the vertex, you can back it up in vertex form. You know that it would be x minus 1 squared plus 2 in vertex form. The reason they're giving you the point on the graph is because it could have a vertical stretch or shrink. And so I like to put a little letter out here, A, and use that point to help me find what that would be. Because this part is for sure making the equation look like this, but this point here says it could be stretched in some way. So what you do is you take that point and you plug it in for x and y. So I'm going to plug the negative 6 in for y and the 3 in for the x. And so that'll give me negative 6 equals 4a plus 2, and then I'm going to subtract the 2, and then I'm going to divide by the 4. So that'll give me a to be negative 2. That means that the equation they're looking for has a negative 2 in front of the parentheses. And this is more specific than those with the zeros that we just did. We know this for sure, and there's only one option for this answer. Okay, in our last example, you can try it on your own, or you can just follow along. Because they gave you the vertex, we would start by saying, okay, that would be x plus 4 squared, and then plus 11, because it would have been moved left 4 and up 11. But again, I don't know what's in front, so I'm putting an a, and then I'm going to plug in the x and y. So I'm going to put the 15 in for the y, the negative 6 in for the x, and then I'm going to say what's negative 6 plus 4 is negative 2. Negative 2 squared would be a positive 4. I'm going to subtract 11. So I'm going to get 4 equals 4a. And then if I divide by 4, a is 1. In this case, a is 1. We don't normally write a 1 in front of the parentheses. So I'm just going to write my equation as y equals x plus 4 squared plus 11. And that's going to give me that equation. And that finally concludes this lesson.